What's going to be the name of this one? So what we're going to do, longest chain again. What will be the longest chain? How many carbons in there? Should we go this way? 1, 2, 3, 4, 5, 6, 7. Like this. That's easy to point out, but you're going to realize that, oh, there's other things you probably should count in. If you go this way, 1, 2, 3, 4, 5, 7, 8. Here you go. What about the other way? You go this way, 1, 2, 3, 4, 5, 6, 7, which is shorter, right? But there should be another way, which is going this way, 1, 2, 3, 4, 5, 6, 7, 8. So in no matter way, 7 is not the one. You gotta use 8 carbon containing chain, but there are 2 of them, right? So 2 of them, one go this way, the other go that way. Which one are we need to use? One's colored green, or the other colored with the purple. Why?
Because the second carbon has a substituent, and that's for the green one. It's not too clear.
The first thing you have to think of a number of substituents, right? So how many substituents are here for the green? The green has a 1 substituent here, and then this whole thing becomes a second substituent. It's 2. And the purple one, how many substituents there? 1, 2. So it's tied up. So this is kind of the things that kind of I was trying to make a point. But the thing is, there you cannot figure out which one we should use based on the rule number 1. Then what we're going to do, we're going to break the tie using the rule number 2. What is the rule number 2? Numbering the carbon chain, right? And then we should number them to get the first substituents as low number as possible. So for instance, if you're using this system, you better start from that one first, not this one. Because if you're using that one, number 1, 1, 2, 3, 4, 5. First substituents appears in carbon number 5. Instead, if you number this way, then first substitutions appears in carbon number 3. Right? That's why we're going to number this way. For the purple one, we're going to number this way too, because that way first substituents appears in carbon number 2. But this is where the tie can be broken for the number 1. First substituents on the green one start with the carbon number 3. First substituent, the purple one, starts on carbon number 2. We're going to make the low number as possible. So which one going to be winning is the one with the purple. So that if you number this way, if you consider this the main chain, first substituents appears in column number 2. So this is kind of an example of the next rule to break the tie of the previous one. This is the number that we should use. So all because, not because of more number of substituents, because both systems have two substituents, but they're in the different conditions. So which one you should use? The one with the low number possible. That's rule number 2, but that's the one that breaks the tie of the rule number 1. So this is a numbering system that we're going to use, and that's going to be the main chain. It's an A chain, so that's going to be octane, right? Octane. We got substituents, methyl. What is the name of that substituent? Butyl, right? Isobutyl. So this is where many people get it wrong. So that's a 2-methyl, and 1 carbon is a simple. When there's a 4 carbon chain here, that is a sec butyl. Why? Because of the branch of carbon has a 2 carbon substituents. That's the one's called the secondary. I just want to point out that that's an isobutyl. It looks different, right? Isobutyl, sec butyl, unprepared eye, they look similar. You can easily make a mistake. Believe me, I've seen so many people. So you need to know what the sec butyl looks like, what an isobutyl looks like. They're different. They got methyls on different position. The carbon, the branch off has a methyl, that's a sec butyl because it's a secondary carbon. That's the last carbon, it's a primary carbon right there. That's the differences. So it's a sec butyl, 2-methyl, Now we're going to put them together in an alphabetical order. What should we put? Two methyl first, because the other one starts with an S, right? It's a sec butyl, must be start with an S, right? So again, most of the prefix doesn't count for the alphabetical order except iso. So methyl start with an N, sec butyl start with a B, right? This is where you get wrong too. So there's a many things that you can get wrong. The correct name of this one, 4-sec-butyl 2-methyl octane. Somehow you got isobutyl in the system. Does isobutyl start with a B? Isobutyl, I told you that's an exception. Isobutyl start with an I. You really should get used to seeing exceptions, especially in chemistry. But I tell you, biology has a tons more exceptions, but nobody complains about it. I don't know why. What about this one? Again, same rule. Rule number one, what is the longest chain in that molecule? Should we go this way? 1, 2, 3, 4, 5, 6. Hexane. Is there any longer or the same one, different, maybe higher priority? If you count this way, 1, 2, 3, 4, 5, 6, 7. So which one the larger? 6 over 7. The question, hexane, 15. Now you need to worry about the numbering. You should number this way 1, 2, 3, 4, 5, 6, 7, or you should number the other way 1, 2, 3, 4, 5, 6, 7. So if you number this way, the green one, then substitutes are number 3 and substitutes number 4, the 3, 4 system. If you number this way, the red colored one, then you get the 4, 5. So 3, 4 is lower than 4, 5, right? So, which means is this is a numbering system that you're going to use. Now to name the substituents. That's an easy, that's a methyl. What about that one? Is that sec-butyl? So nobody make the mistake with T-butyl, right? That's the easy one. These two are the most confusing one. That's a told you, you really want to know. That's a T-butyl or tert-butyl, tertiary-butyl, all the same thing. Put it together. Tertiary-butyl, does it start with a T? I guess you probably know why I'm asking this question, right? Is T-butyl start with a B? Prefix doesn't count, except iso inside. So T-butyl at the 4 position, 4-T-butyl, 3-methyl heptane. So if you just follow the rule, you can get there. Question. Okay. What about drawing from the name? You should be able to do both things. You should give a name for the structures. You should draw the structures from the name. Drawing the structures, you just have to do it in opposite directions. I mean, yeah, 3-methyl, 5-propyl there, but what you should probably consider most is a no name, because that's a parent chain. Where's a no name? How many carbons in there? This is kind of a strange because no name is not something to be talks every day, but that is not. So 9 carbon. 9 carbon, is each to just draw the straight 9 carbon chain. The thing is that carbon number 3 has a methyl, so carbon number 3, we just put the methyl. Carbon number 5, propyl. So what is the propyl? The one with the wedge dot. I mean, N propyl you may know, but you knew that when you see something without N propyl, means the same thing. That's a 3 carbon chain. Is this the only drawing that you could do? No, you can draw the other way if you want to. You can draw upside down, you can flip it around, but no matter what you draw, all the connection that we talked about doesn't change. If you draw this way, it still should be saying 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. That's the main chain. These are substituents there. So we can figure out whether they are same or different one. So it doesn't matter how we draw it, we should figure it out. But we draw it, you should know how to figure it out.
But both of those are correct.
Yeah,
right?
both of them are correct. You can draw any different way. You can draw even 1 here, 9 there. There's so many different ways to draw it. So we will figure it out. Don't worry about it. That one, I'm pretty sure you can figure it out. Only thing you probably need to worry about is what is the isopropyl, right? Isopropyl is this one. Not the free carbon that we just picked. Isopropyl is something that you probably see a lot, so I hope you know what it is. But again, this can be drawn, this way, that way, different way. Doesn't matter as long as they got the same information.